Good morning, good afternoon, and good evening, and welcome to the Docxonomy Intelligent Webinar Series. My name is George Lyon, Chief Commercial Officer here at Docxonomy, and the topic of today's webinar is going to be on intelligent archiving and application decommissioning. Our goal today is to show you a very affordable and easy way to archive legacy content and also to decommission legacy applications. We're happy to lead this discussion today with us, Brian Reynolds, our founder and CEO. And Brian's going to walk through a few slides introducing you to Docxonomy and a little bit around our intelligent archiving solution, and then run into a thorough demo of the application. So at this point, I'll turn the webinar over to Brian, and he can carry you through for the next 45 minutes or so. Brian?
Thank you very much, George. Thank you all for who are in attendance. We are very excited about talking to you today. I'm glad you all were able to join. We are going to be covering intelligent archiving and application decommissioning. As George stated, we're really excited about telling you about everything that we have going on in that space within Docxonomy. We will be going through a few slides and we'll be covering a demo. With that being said, let's go ahead and dive right in. As George said, my name is Brian Reynolds. I live in the Philadelphia area, and I have been in this space for quite some time, coming up on 3 decades now that I've been focused on enterprise search and unstructured data management, really in particular around document management. I owned and ran a software consulting company for about 13 years. I sold that to EMC several years back. I worked with them for about 3 years in a global role. And then since then, I've left and started another venture, which is Docxonomy, which we're very excited about sharing with you today. With that being said, there are a few webinar logistics that we'd like to cover. The main thing is you have the interface bar at the bottom of the webinar that allows you to interact with us. It's pretty self-explanatory. However, everybody will be muted during this session. There's quite a few on, so we'll just be giving a presentation. If you do have questions, we have people available that are online to overseeing the webinar. So please feel free to click on the Q&A button and ask those questions. We will try to answer those questions in real time. If there's a question that requires a little more in-depth answer, we will respond via email as well to any of those questions and get those back to you. So let's talk a little bit about Docxonomy. So kind of diving in. So established the company in 2017 with a group of really great people that are ECM experts. We have over 75 to 80 years combined of deep consulting knowledge around unstructured data, dealing with the actual documents and files and all the various sort of unstructured components that get created within an organization. We came together to develop out Docxonomy with really kind of a key focus. We wanted to change how enterprise search is accomplished. We wanted to deal with both unstructured in particular, which makes up about 80% of the data out there, and structured data. We wanted to do this in a very effortless, affordable way for all companies, big and small, to be able to take advantage of. Which kind of leads us to the mission and the vision that we sort of set forth. We really wanted to come up with a way for anybody, and especially big, large corporations, to access affordably all of their files. We wanted to change how search is done against these types of repositories and make them more intelligent. And we wanted to leverage IP that we've created, intellectual property that we've created, to allow customers to gain insight and vision into this large, huge repositories of data. That's why we do what we do, and we're very passionate about that. That being said, we're experts really at dealing with structured and unstructured data. We're experts at identifying hidden meaning. I've had so many people come to me in the past and just tell me, I know I have these files, I know they exist, but I can't find them. I mean, it was in an email. Is it on my Dropbox? Is it in the file share? Is it in Documentum or SharePoint? I know it's out there, but I don't know where it is. And so I have to go to all these different places to try to find it. And it's frustrating. We heard this time and time again. I don't know how many times I've had this told to me through projects that I've worked on over the years. Especially in a day and age, we thought this was just crazy because in this day and age, we can Google everything. I'm sure every person on this webinar today has Googled multiple times today to get answers to something that's out in the public domain. We're used to getting the scores, the weather, the news, whatever you name it. You search on it, you can find it in Google. But the problem is you can't do that for the data that's behind the firewall. You don't have that same experience in all of the dozens, hundreds of different systems that your company interfaces with over and over and over. So we wanted to bring that to the masses, right? We wanted to change how that operation happens. And what we wanted to do was use machines to read content like human beings. So we use artificial intelligence, we use machine learning, we use natural language processing, and we go through the process of taking your content, regardless of where it is, and understanding what it is and raising that meaning up to the surface so that then you can answer questions. You can interact with your content just like you do with Google every day. This is what we wanted to accomplish. This is what we've done. So when it comes to Docxonomy, we have several solution areas that we're focused on, right? And those are listed out here across the slide here. So we focus on search, we focus on migration, we focus on governance, and we focus on archive. These solution areas are growing all the time. And as we have more and more conversations with customers, we find more and more ways that we can help them enhance their data repositories and make them more intelligent. However, we're going to focus on these areas today, and in particular, we'll talk mostly about archive. But I want to give a little context around these solution areas and some of the things that we can do as it relates to these. So you'll hear us talk about intelligent processing. Intelligent processing is quite powerful. It gives us the ability to look at content as it comes into the system and have a machine analyze it and identify what's important in this content. We do what we call auto classification. So when a document comes into the system or any type of a file, we can tell, oh, that's an invoice. Oh, that's a study protocol. Oh, that's an email. We are able to auto classify what kind of content it is that's coming into the system. And this is all automatic. No user involved. The system's trained to do this. And it's just a machine actually doing the work. We also have the ability to extract intelligence out of the content itself. As we talked before, we read these documents much like a human being would read these documents, and we lift meta information or entity information out of the documents. We understand things like places and dates and locations and whether it's a person that's being talked about or whether it's a drug name or something like that. These will automatically be attached to the index and become searchable without any human involvement. We also have the ability to use what we call discovered metadata, and this is in particular important around governance. So for instance, if you want to identify all the content that is in any of your repositories that have a social security number in it, or maybe it has a medical identification number or passport information, you can set up and configure within the system, and our system can automatically identify and tag and then be configured to take action. Should I route this to somebody for review? Should I change the permissions on it? Things like that. In particular, around this particular webinar, we're focused on archive. So we're going to talk a little bit more in depth around what we can do from an archiving standpoint. So let's talk a little bit about the challenges of archive. There are 4 key questions that we can ask that we put together for this particular webinar. The first one is very simple. Is your ability to archive the content that you have today a painful process? What we find in a lot of the conversations that we've been having with our customers over the years in past and more recently is that you have a lot of legacy applications, whether they came in through M&A where you had a large merger and acquisition and you inherited applications and you can't get rid of them. You have to continue to maintain them. So, it's basically an archived application. It's not being used on a regular basis, but you need to gain access to it every now and then. So that's painful to you to keep that going and keep it running. The other case may be is that you have a legacy application or an archiving solution in place, but it's super expensive to maintain. Maybe it's very costly, the annual maintenance on that, and it's not very user friendly and not easy to use. Or if you don't have an archiving solution, you look across all these vast archives, you might have dozen or more or so 100 applications that are sitting out there that you can't afford to lose. You have to keep them around, but you really can't afford to maintain them. It's super expensive, and you'd love to be able to allocate that budget to put it somewhere else, to put it to better use for the organization. And finally, another question that we ask is, can you search your archives if you do have archives, whether they're in a non archive solution or just out there? Can you search them like you do Google, like we just talked about? So these are kind of 4 sort of key basic questions that we can ask. And what we find is most of the time the answer is no, we're not achieving these. However, when we look at Docxonomy, we find, and we believe you'll see when we demonstrate this, that it's super easy to use our application. It provides visibility like you never could before. You'll be able to find stuff better than you can in the current application that it's running in just because of what we do. So we feel that, your pain factor is going to go way down and you're going to be much happier when it comes to that. On another note, we feel that, as you'll see, it's much more cost effective to utilize Docxonomy. As we said, we set forward to create an affordable solution, one that would make it much easier for everybody to be able to use. And I think you'll also notice when you get into the application and we demo this, that it is very Google-like and that it very much gives you the ability to have answers and visibility and insight to content that you just didn't have access to before. So let's talk about sort of the scenario here of what we're going to be demoing and what the costs are associated. So first and foremost, there's the cost of the status quo, really doing nothing. So let's say you have a legacy Documinium application and some legacy database and a legacy file share, and you have an M&A from mergers and acquisition database and another M&A SharePoint system. And those are sort of taking up a various amount of storage. So you've got a terabyte of Documinium data and 10 terabytes on a file share. And, so there's a lot of information that's floating out there. There's an annual maintenance tag to each of these. So say for Documinium, maybe it's around $250,000 a year that you're having to pay to keep the software under maintenance. Maybe for Oracle, it's another 200, and for SharePoint, it's 175. And these numbers are derived. I mean, they'll be different for each company, but these numbers are derived basically from our experience of doing implementations like this. And also to note, and I think it's important, is that you also have support tied to these. So you have people, full-time employees. And so we've allocated a percentage here. Let's say 0.25% here and 0.25% there. And you can see the numbers as we outline them here on the slides. So when we take that and we bubble it up, we'll note that it takes about $210K using a sort of fully loaded cost of $120K per FTE to manage these applications over a year, all right, per year. And then you've got another $775K in hard maintenance dollar costs that you need to be paying out to the various different vendors that support these applications. And these applications aren't even being used today, or you don't really have great insight into what's on these applications at this point. They're just there. You're maintaining them for regulatory reasons. Every now and then you might have to get into them, but you're not really gaining any value. So that kind of bubbles up to an annual cost of $985,000. And this is the status quo. I do nothing, I have to continue to pay this. However, let's sort of take the same set of applications and let's look at them as if I chose to migrate them or to archive them to a traditional archive solution. And there are many of those out there. I'm not going to name any, but we all sort of know who they are and where they stand. These are traditional applications. They're complicated. They probably require a lot of coding effort, a lot of consulting effort. They're not simple to use by any means. And then once they are implemented, they're pretty rigid in what you can get back. You have to really, really design all of that up front and put a lot of effort and thought into the content that's being migrated into it. So let's assume we're going to use one of these to migrate this content. Now, for the amount of data that we're talking about migrating here and putting under control, from our experience in doing a lot of consulting projects, you're probably going to be looking at around $750K for the licensing to handle a migration, an archive migration of this sort, right, of this size. And so when you look at that, you also have to realize it's probably going to take at least a year to get all of the project work done and get it implemented in place. So when you look at that, it's going to be, you have to pay that current year, plus you're going to have to pay the software so you have it. You're looking at about $1.74 million in total cost just to deal with your current status quo for that year and to procure the software needed in order to migrate the content over. So this doesn't even take into account any project work that's associated with getting this over. Now, when we look at that same scenario from an intelligent archive standpoint or from a Docxonomy standpoint, we look at things from a user and storage standpoint. So it's just important to kind of note that. So when we look across this repository, we say, okay, we've got 14.1 terabytes worth of data to store, and I magically picked 500 users. This could be 1,000, it could be 100. This is totally adjustable based on your requirements, but we just picked 500, all right? So if we look at, we're going to give 500 users access to this repository, and we're going to archive all of these 5 solutions into, the Docxonomy archive. So first off, because we use connectors and they're pre-built, and doesn't require coding and it doesn't require a lot of the complexity that it takes to migrate the content, we feel, and we're being conservative, that you could get this system up and running and migrate your content over to it in under 6 months. So we'll use 6 months as a number. So that means you only have to incur 6 months of that cost. So we're taking 400, half of basically the 1 year status quo cost, okay, that you're going to still need to have in place while this goes on, okay, $492K. The other side of it is, in order to archive this content to our solution, it's only going to be $366K for the software cost, right? So significantly less. It's half. It's basically half, actually probably under half of what the other solution would be. So when we add those two things up, we're at half or half of the cost already of what a traditional archive would be just to utilize our intelligent archive. And this is just on the software side of it, all right? But let's kind of take this a little bit further and let's look at these side by side. So if we look at this and we kind of look at this across those same applications and we're going to archive them, if we look at a traditional archive, we see that, we have the 1 year current cost, because we still have to cover that, $985K. We have the annual reoccurring $750K cost. And remember, that reoccurs every year. And then being a consultant and coming from that background, it's usually about 2x what the software cost is, right, for the services that go along with it. because we know that these solutions require a lot of effort, a lot of coding, a lot of configuration, a lot of work to get them to work. So when you add all that up, in order to get these 5 systems archived, you're looking at about 3.2 million in order to just get this thing off the ground and get it going. When you look at Docxonomy as an archive, again, because we cut that current cost in half, we're going to take that out, which we think would even be less. Our software costs significantly cheaper, less than half of the traditional solution. And because we have pre-built connectors and the work effort associated with setting all of that up is far less complicated, when you add all that up, you're going to end up being more around 1.1 million for that project. And it may even be less, to be honest, because we believe you can get quicker than 6 months to where you need to be. So what does that time to ROI look like, right? So from a traditional application standpoint, that looks like this. So when we look at the traditional, you will get to a place where you can get 235K in savings that can be applied to your budget for other purposes, but you won't be able to achieve that because of the overall complexity and cost of the project for at least 3 years. However, with Docxonomy, you get much more, right? You're going to actually recover 619K of your current status quo cost and be able to apply that to new budget, and you'll be able to get there within a year based on these numbers, and it may even be less. So very compelling story, very compelling, vision that we see here. And I think one of the reasons why we want to share this information with all of you. With that being said, I'm ready to dive into the demonstration. So I'm going to switch over here really quick and transition to a different screen and bring this up. And let's go ahead and take a look at this. Okay, great. As we switch screens here, so as we get into this demo, I just wanted to kind of preface a couple things. So the content that we'll be looking at today is life science centric. That was pretty much due to the number of life science accounts that signed up for the webinar. However, by all means, it is not restrictive to life science. We can support many, many different document types. And if you have a need to get into more specialized demo or look at your content, you can feel free to reach out to us. We'll be happy to give you a tailored demo specific to your industry. In addition to that, all of the content that you see, regardless of what it is not anything that is not publicly available. So you'll see documents, you'll see customers' logos and things like that that are mixed in to this demo set, but it's all stuff that came from publicly available websites. And there's nothing in here that's proprietary in nature, just to make everybody aware. I'd like to start it out that way. So with that being said, let's dive right in to the user interface. So we're going to approach this demo in a couple of different ways, right? So the first thing we're going to do is go through and actually show you how easy it is to navigate the user interface and some of the features and functions available in the UI. Regardless of archive, this would be applicable to anybody and how they use this application. And specifically, we'll show you from an end user standpoint how you will search it for data that may be part of an archive. So we have some of that loaded up in here, and we'll show you that. So we start out from a search interface. So everything today, we're all very accustomed and used to doing searches. When you log in, the very first thing you see is a search interface. So let's dive in and do a simple search. So in this case, I'm going to search on the word hydrochloride. Execute that search, and it's going to run and return a set of results. So for us, it comes back with 9 documents, 9 files that return in the result. And just to kind of give you a walkthrough or a lay of the land of the interface here, you'll see the results come back in a list-like format. We can absolutely toggle and view in more of a gallery type view. where we can sort on that, but we'll stick to the list for now. I'll also talk a little bit about insights in a second. But the first thing that you see here is you'll see the color highlighting. So all search results bring back snippets from within the documents of the content, and we highlight the search term, but not just the search term by itself, but its mention or its use. Basically within Docxonomy, due to our natural language processing engine and the ability to read content more like a human being, we're able to understand the context of a particular word and make those associations as their relevance when they're being scored. You'll also see across the top here a blue bar that identifies various different attributes that we pulled out within the search result that are named entities that are important. And we can kind of toggle through that and click through that. You'll also see on the left-hand side here a series of facets, or what we call aggregations, where we've rolled up various different important attributes that were automatically lifted from the document that were important. And one of the things that I want to kind of focus on here is the sources area, because we're going to dive a little bit deeper into this. This was a search that searched across all the content that was in the repository that met the requirement. But we'll notice here there are two sources that it's being referenced across, and those sources actually represent archives. So we have set up 4 fictitious archives for the demo. One is called BLFS protocol, another one's called DCTM master file, and there's a couple of SQL database related archives as well, where we archived a Microsoft SQL database and a MySQL database. So we can easily click on these and filter down to those particular documents. So in this case, we see that these are protocol. It's a protocol system, so these are protocol related documents. We can hover over the icon here to get an idea of what that first page looks like. We can actually click on that document and go into it. So let's take this RAD 01 document here. We'll go ahead and open it up into our viewer. We'll notice here that we continue to carry on the highlighting. So when we actually open the document, we have a textual view, and we bring up, again, as I said, the context or how things are related. So all of these words here act as a phrase within the system, and they're linked to the hydrochloride highlighting. You'll also notice here that we've jumped about halfway into this document, which is probably rather long, in order to see where that is, and we can navigate through that. Of course, if you want to view the original content, you can click on the view and see it still in its native format. This is a long document, 62 pages long. But the reason that we use the text viewer is because it allows you to very quickly jump through and analyze content in a much faster fashion without having to read the entire document to try to find the key attributes that you want. So we find this to be a very effective way to quickly get through content a lot faster. So let's change our search. Let's go back to the search screen now, and let's kind of go a little bit different. So we're going to kind of do more of a general search right now. We're going to search, but we're going to limit it to a particular system. So in this case, let's go ahead and show our sources, and we'll choose from the drop down the source that we want. And I'm in particular looking at this Documentum one for now. Okay, so I'm going to choose that I'm going to search on the Documentum master file source, and we're going to go ahead and actually search on the word medication, which is a broader search. And now we've limited to just this one specific archive that we're looking in. And of course, we got 40 results that came back from that have the word medication or the context of medication and use associated with it within this repository that we brought over. And these are medication guide documents that were in this particular Documentum repository, so we can see the classification of those here. But let's fine tune this a little bit further down. Let's basically say we're going to change this out and say we're looking for a specific drug, Kevzara. So we'll go ahead and execute the search against Kevzara. we're going to get a result back. And now we're looking at one record that came back for this one file. It has 25 results, but that's because of the children. And I'm going to explain sort of what we do with children right now. So if we open up this medication guide, we're going to see the name being highlighted in here. There's 106 references to it within the text. It's a rather large document. We can, of course, again, like I said, click the viewer and view the document in its native format. But you'll notice inside here, there's a lot of images that are embedded inside of this particular PDF. And I just want to note, you'll see over here in the child references, we actually extract all of those children and we pull them out and analyze them independently of the actual content. So we try to dig deeper and deeper into whatever we process as it comes through the system so that we can understand it even more and make that all part of the index and make that all available from a search standpoint. So let's go ahead and click on one of these images. Let's actually click on this guy right here. So what we'll notice here is that we actually brought this image. It was embedded inside of that PDF, and we processed it. We did some basic processing. We tried to OCR it. We try to OCR everything that goes through the system so that if we can find content in it, and we don't guarantee perfection, but we'll see. We got the name of the drug in there. We actually got the subname or other scientific name associated with it. We picked up the word expires. We were able to read that. And so this all becomes part of the index as well. So if I was searching on, say, this particular value here, then this image is the only place where that lives, and I actually found it, I would always have a source back to the actual parent, which would then be able to get me to the actual document. And in traditional search systems, that's just not possible. So again, all part of what we do, whether you're archiving, this is sort of showing the intelligence, or at least beginning to bubble up into your minds, the various different things that we can do from that standpoint. Let's do another search here. Let's actually go back here, and in this case we're going to do a broad search. So we'll remove the source, and we'll just actually do a search on the word Blinkcyto. As you can see, we get one result back, and it's an image. So I just wanted to show the image processing a little bit here, just so you can sort of see what happens. So let's go ahead and click on that and open it up. And what we'll see here is the highlighted term comes back for the text that's relevant. So I talked about that we OCR all text. So in this case, this is an image. It's a JPEG image of a label that was loaded into the system. And you'll see here that we've highlighted the word that we were actually searching on, which was the Blinkcyto. But you can see across here, the OCR that we've done on this is really, rather well. So all of this information from this image is all searchable from a text standpoint. So if I query and search the system, this is going to come back if I'm searching on this particular word, as it just did. In a traditional system for images, that wouldn't happen because this is image-based. So you would maybe get property names like file name, size, things like that, but you wouldn't be able to search for it for the content or the intelligence that lives within it. So this is something that we do. But looking at this image, we also analyze images in a totally different way too. So we actually look at the image and we try to understand what the image is about. Now, in this case, it's a label. So we understand that there's text there and we understand color and things like that. But we can also tell logos. So we picked out Amgens in there. We also can tell that there's dosage information that's in there. We understand that it is, related to a product, things like that. And so you can see from the relevance graph, all of these values are also indexed and searchable on any image that we find. So that's all, really powerful and intelligence that is applied to the overall system, regardless of whether the file is uploaded or it's coming, in this case, through an archive. So let's jump back to search again. And let's just do a broad search. And in this case, we're going to actually search on the word Botox. Kind of a broad search term. We have a lot of things in here related to that particular drug because it was available online. So as you can see here, we got well over 100 results. which maxes out, the settings that we currently have to return, 100 to the UI, and so which is far more than we need to see. So, but searching on just a simple search term like Botox isn't good enough. We want to basically be able to ask questions of our system. When we think of the use of Google and things like that, we ask questions of it every day. So let's go ahead and actually ask a question of Docxonomy and see what we get back. So instead of searching on Botox, we're going to actually ask the question, how many Botox procedures have been performed? As we can see, the results come back real quick, and based on the information that is stored within the system, we get an answer to that. It's based on content that's in the system. Approximately 11 million Botox cosmetic procedures have been performed since, and that's just the snippet coming back from that. What's interesting about this, though, is this came out of a video. So what's different about video? We process videos and we analyze them in a lot of different ways instead of it just being a file that gets uploaded. We analyze the imagery in it, as you can see over here, just like any other child, and we pull out attributes that are associated to each of the different images within the video for each frame. We also auto-transcribe what's being said and convert that to text so we can analyze it. And that answer that we got actually came back from a video and what was said there. So as you see, we can click here and jump to that segment.
Frown lines between the brows in people 18 to 65 years of age. Approximately 11 million Botox cosmetic.
So the answer came from something somebody said that was embedded in a video. So very powerful stuff. So one last search as we kind of move on, and I want to be mindful of everybody's time. One last search I want to do is more around a structured database query. So we did an archive of some databases. So we're going to go ahead and come in and choose a MySQL food research database that we called this, okay? And we loaded information in. And we're going to ask a question again, same thing that we did before. We're going to ask a question, and we're going to say, how many genuses are there for Angelica? Angelica is a type of herb. So, and again, searching against data that came from a structured SQL, MySQL in this case, database, we can see that we get an answer back saying that Angelica is a genus of about 60 different species. So again, just showing question and answering, working against structured data. We've seen a lot of it already with unstructured data. We support both. We can also click on this record for Angelica. We call it a food item. And we can see that it comes back a little bit different. Because it's a database and because it was set up, we have a name, we have a scientific name, a description that was collected, a group and subgroup. And then we have some additional information down here we can see. These are the chemical compounds that are made up for that are classified out for that particular herb. And of course, within the grid, we bring back all that data. There's quite a few records here. And we can do things like we can do grouping by subclass, and then we can kind of sort the data. We can search across the data records. And this is all completely configurable based on the records or the information that you want to bring back from an archive. So from an end user standpoint, it lets you get to that data real easily. Now, I'm going to switch a little bit here, and we're going to jump to the back end of this and how some of this gets configured, because one of the most powerful concepts is how quickly you can set this up and implement it and getting used and get it into use based on how we've configured and constructed the engine. So let's go ahead and shift from a user, just querying and looking for data within the repository back to the backend. So we'll click on the Life Sciences login here, and we're going to click on the admin screen, which is going to put us into the back end of the system. Most regular users would not see this. It's not something an average user would ever have to do. This is more from an IT or an administrative setup standpoint, but it's to sort of articulate what goes on. So one of the key components that we have on the back end here is a thing called file classification. So you can see here I set up a few different file types that I'm managing. These are custom file types. And the system is has a built-in training mechanism for you to create your own document types. And you can have as many as you want. There's no limit here. All you need to do is give it a name, choose from a master class. In this case, I chose Life Science Document as my master class. Give it a description. That can be whatever you want it to be. You select a folder of files that are already, that are match up to that. They can be all mix of different kinds of files. It doesn't matter, but they're all a medication guide or a microbiology review or packaging data, however you want to name this. And then you upload those. And once you're all set up and you're ready to go, you click the train button, which is disabled because I've already trained, and it will go through and train the system based on that information. And now, anytime a document, no matter where it comes in from or how it comes in, through connector or whatever, it will automatically get classified based on this information. But to train it, all you got to do is give it a name, point it to some files, and then let the system do the training for you. Nothing more needed than that. From an external data standpoint, you can actually see here, we'll go ahead and click on this. We also have pre-built agents and connectors that allow you to configure the crawl for all of these repositories that you may have. We support many different ones. You can go to our website to get a list of all of them. We're referencing here, in this case, Documinium connector. We've got a file system connector and a couple of database connectors for this particular demo. But let's go ahead and take a look at, for instance, the My Food Research one, which is a raw pure SQL data connector. So we give it a name and a mapping type. This is, what do we want to call these objects when they come in? We associate any permissions associated to them. In this case, we're just going to everyone. We schedule when we want it to run, so we can run monthly, weekly, daily, every X minutes. It's completely configurable. We choose the type of connector that it is. This is a MySQL connector. We support Microsoft SQL, MySQL, Oracle, Postgres, and MariaDB today. We can definitely choose others if there's demand, so we just need to know. We'll build connectors for those as well. We give the database root name and the password needed to connect to it and the location and port that we're talking on. We choose whether it's report-based data, meaning it's just query table-based data, or whether it's binary data, meaning like files that are embedded as blobs in the database. We tell it the database name that we're going to connect to. We build out our query, whatever that query may be that we want to use to collect the data. This can be quite elaborate and get as deep as you want it to go. And then we set up a mapping. So, how do we want the data to be displayed in the UI? So we can set up a property set, grids, lists. We can associate the values. We can tag the entity types, the format, the data type. All of this information is all configurable. You set this up and save it. You map it to the database driver needed. Again, this is, like I said, an IT thing, but very straightforward. And then you save that. And you do that for all your different file types. So that was a SQL database. We could look at, for instance, Documinium. It's very similar, all the same sort of setups, except now it's asking for the doc broker port, things like that related to Documinium. Same thing for a file share. It would want to know, file share information, the path that you want to crawl. All of this is configurable. And you set these agents up, and then you configure them to run. The connector gets created, you create an agent, download the agent, deploy it onto your network, and then run it. And then based on the information that you provided underneath the connectors, it'll execute and run and crawl that data and index it for you, all on the fly. It's all configurable. There's no custom code needed, no complex deployment. Everything is there and available for you to run this and get started day one. So I touched on a lot of different things. I think we're coming to the end of our time here. I know that there were probably some questions that were being asked along the way. I'm sure the team that's on this with me were answering those questions. I just want to note and let you know that if you have any further questions, you can reach out to us at any time. You can find us at canyoufindit.com or at docxonomy.com, whichever is most convenient for you. You can follow us on Facebook, LinkedIn, and Twitter as well. We're constantly sending out new updates and new information, new blog posts, things of all that nature. By all means, anytime that there's anything that we can do for all of you, feel free to reach out to us. That's why we're here. Again, we thank you very much for attending. Have a pleasant day, and we look forward to talking to you again soon.